So this week we are going to start working on Chapter 5, and the models that we are working on Chapter 5 are mainly examples that are coming from service industry, a call center, a bank, a restaurant, and so forth. There is no difference between modeling a problem in the service industry or in the manufacturing industry, similar to the problems we did in Chapter 3 and 4. It's just that some of the new techniques that we want to learn are a little more applicable in the service industry. But all the techniques that we're going to learn in this chapter, you can apply them in any problem context that you may face later. Okay, so this is the model that we're going to work on in this session. Hopefully we will be able to finish it, if not next session. So first of all, we are in week 8, right? So create a folder for week 8, please. And inside that folder, we are going to create a blank model, and we are going to call it Model 5.1. That's Model 5.1 from Chapter 1, and dash call center. Okay, Model 5.1 dash call center is the name of this new model that we are going to build. And please save this model in the folder for week 8, which corresponds to this week. Okay. So now, please stop whatever you're doing and pay attention, because I want to explain the structure of the model, and you have to know the structure to be able to understand better why we are doing some of the things that we are doing in the model. So this is the model of a call center. This call center works from 8 a.m. to 6 p.m. The calls arrive, the inter-arrival time has exponential distribution, 0.857 minutes is the inter-arrival time. And when the calls come, they are going to be answered by an automatic recording. And these automatic recordings ask a bunch of questions and then defines the type of the calls that we have received. It's either a technical support call or a sales call or an order status call. 76% are technical support calls, 16% are sales calls, and 8% are order status calls. If they are technical calls, and then the time for this automatic recording to basically decide what type of call we are receiving is uniformly distributed between 0.1 minute and 0.6 minutes. Okay, so that's the time for this automatic recording to decide the type of the call that we are receiving. And if we get technical call, then technical support call, then this call can be related to product type 1, product 1, product 2, or product 3. Again, defining which type of product this call is related to is done through an automatic recording, and the time that takes this automatic recording to do this specification is uniform between 0.1 and 0.5 minutes. I forgot to put the percentages here, but if you are taking a note, please write these percentages. Product 1 calls are 25% of the calls. Product 2 calls are 34% of the calls, and product 3 calls are basically the rest, which I think is another 30 something. Okay, so the rest of the calls are product 3. So product 1 is 25% of the technical support calls. Product 2 calls are 34% of technical support calls, and the rest of the technical support calls are related to product 3. When finally these calls are assigned to, depending on the product type, it takes a triangular distribution, minimum 3, mode 6, and maximum 18 minutes to process these calls. Okay. In terms of the staff that are working in the call center, we have 2 technical support people who are in charge of product 1. We have 3 technical support people who are in charge of product 2, and 3 technical support people who are in charge of product 3. No matter which type of product this call is assigned to, all of them take this amount of time to get processed: triangular, 3, 6, 18 minutes. Okay. And if we get a sales call, we have 4 employees on the sales assigned to the sales call, and the time to process a sales call has triangular distribution, minimum 4, more 5, and maximum 45. And if the call is order status call, order status calls do not need any person to answer the call. These calls are answered automatically by the automatic recordings, and the time to answer these calls takes any time between 2 minutes to 4 minutes, triangular distribution with mode 3. Okay. And then when we get an order status call, which are only 8% of our calls, and we let the recording to help them to find the status of their order, about 85% of those calls basically say goodbye and leave the system. No questions, nothing else. Okay. Okay, sorry, they changed these percentages. 15% of them have sales questions as well, and 85% of them have no sales question. Okay, so just change, so the idea is correct. So out of those orders that are coming for order status check after the answering machine answers them, 15% of them have additional sales question, so they need to go and talk to a salesperson. 15% of them have additional sales question. 85% of them have no sales question and leave the system. So just change the percentages on these 2 branches. I wrongly put the percentages. Okay, 15% of them have sales question. 85% of them have no sales question and leave the system. For those that have sales question, they need to go and talk to a salesperson. However, these calls have lower priority compared to a sales call that has originally come in. So if there is a, let's say, a sales call in the line, already there's a person has called and has sales question in the line. And also from here, we have a person who has called to check the status of the order and has some additional sales question. This person will have lower priority compared to the calls that has come to the system originally as a sales call. Okay, so we just want to learn how to capture these priorities of these entities that need the same resource. They need to talk to salespeople. However, sales calls have higher priority than order status calls who later have some sales question. Okay. And then there are 26 lines, phone lines, what they call trunk lines. There are 26 phone lines in this system. When a call is received, if all the lines are busy answering a customer, then the customer gets rejected. So if all the 26 lines are busy by the other customers that have called before, then the customer is going to be rejected. And one other thing that we want to make sure to capture in this model is that, the call center works 8 a.m. to 6 p.m. After 6 p.m., we do not let any new customer to comes to the system and any new call to comes to the system. Okay, so at 6 p.m. we just caught no new call comes to the system. However, we are going to continue working till all the calls or all the customers that are already in the system get the service and leave. Okay, this is very, very important characteristics that you guys are going to learn how to model, because it's the characteristic of a lot of the systems around us. For example, if you look at the barber shop, a supermarket, a lot of these systems around us have these characteristics. At some point, they close the doors and they do not let any new customer comes in. However, they continue working till all the customers that are already in the system get the service and leave. We are going to learn how we are going to model these type of systems. Okay, so this is the structure of the model. Is there any question on the structure before we start the model? Okay, so let's start working on the model. So everyone has a blank model saved in the folder for week 8, named as model 5.1 call center system, right? If that's the case, then let's start building the model. So first, obviously, I need a create module to be able to start creating the entities or the arrival of the entities. I'm going to call this create call arrival. And the entity that I'm going to work with is our incoming calls or calls, and it doesn't matter. And the inter-arrival time, as we said, has exponential distribution. Value is 0.857 unit minute. Don't forget to change the unit. And so for now, keep this as entity per arrival 1. So obviously, if we are going to run this system and there is no limit on 6 p.m. when we close the store and things like that, we want these entities to come to the system for as long as we run the simulation. Maximum arrivals we want to be the infinity, and we want these entities to come to the system one by one. Okay, so the calls are coming to the system one by one. And however, given the situations that we are going to handle, the fact that the calls have to stop coming to the system after 6 p.m. and so forth, we are going to learn in a little bit how we have to change these two possible values so that we can capture the fact that after 6 p.m. no call comes to the system. But for now, just keep them as 1 and infinity. Okay, press OK. Okay, next, we are going to, I want to record the calls that are attempted, or the calls, the calls that are attempted in this system. And I know this is one of the factors that the simulation automatically records for us, the number of entities in and number of entities out. But just for the sake of learning, just see how we are going to do this. So I'm going to here record attempted calls. Okay. And can someone tell me how should I do that? You guys know this already.
We can just do count. Okay. And then just name it count attempted calls.
Okay, so count, so I'm going to just count it by 1, increase it by 1 every time a new entity comes to the system. And I'm just going to call this a statistic as attempted call. Okay, it's easy, all of you can do this. Press OK and press OK, and make sure to save as we go forward. Okay, so remember here I said when a new calls come to the system, if all the trunk lines, if all the 26 lines in the system are busy, the call is going to be rejected right away. We are not going to even decide what type of call we are dealing with and so forth. So the call is going to be rejected right away. So let's do that. So let's see let's see when a call comes to the system, we check the very first trivial thing. Do we have enough line to answer the call or not? So for that, I need a decide module. Okay, so I'm going to put it trunk line available. Okay, and here, instead of two-way by choice, I'm going to put two-way by condition because I want to put a condition. Okay, so let's put two-way by condition. Okay. Give me one thing. So let me just explain one thing before I continue forward. So remember, in the system, we have a resource, we call it trunk lines, and those are 26 lines. So those are basically one type of resource that we use as well. So here I obviously have these technical support people, 2, 3, some sales related people and so forth. So they are obviously my resources, but I also have another resource. Those are my trunk lines. Okay, so when a call comes to the system, depending on the type of the call, I not only use one of these technical people, but I also use one of these trunk lines that are available. And for as long as the call is in the system, that resource will be seized. Okay, so then let me just go ahead and define this resource in the simulation model. So let's go to the resources. Resource data module, click here. And here I'm going to call this resource as trunk line. What is the capacity, meaning how many of these resources we have? We have 26 lines. And do not put anything else. We don't have any failure associated with this resource when at some point it's not available, no cost associated with it. We don't specify any other thing. So just define trunk line as the resource is fixed capacity, meaning that for the whole simulation line, we have 26 of it, and that's it. So define that. So that's going to be our resource. So what I want to check in this decide module is to see if the number of trunk lines that are available in the system is less than the number of ones that were scheduled to work. So 26 trunk lines initially were scheduled to work for the whole day, but how many of them are available right now? If the number of ones that is available is less than the number of ones that have been scheduled to work, that means I still have a line to assign to arriving call. So if the number of ones that are busy is less than the ones that have been scheduled to work, then that means there is already a trunk line that I can use. Okay, so I need to check the number of trunk lines that are busy and then compare it with the ones that have been scheduled to work, which are 26. And then if the number of trunks that are busy is less than the ones that have been scheduled to work, then we are good to just allocate one of those lines to one of these incoming calls. Okay, so let's go here. So we are going to have a two-way by condition. And here I'm going to pick expression. Okay, so for this decide module, previously we had used two-way by chance. Now I want to put a condition. There is no chance, because what is the condition? I want to check the number of trunk lines that are busy and compare it with the ones that have been scheduled to work. So from this box, pick the expression, and then right click on the expression box and pick the build expression, and this is where we are. Okay, so on the basic process variable, click on the resource, and then click on the usage. Okay, so click on the usage. So we click on the, just to make sure everyone is with me, click on the basic process variables, click on the resource, click on the usage, and then you have these options. Now I want to check if number of busy trunk lines is less than the ones that are available, that have been scheduled to work. So which one do you think I have to pick to show the number of trunk lines that are busy?
Current number busy.
Okay. So when you click on the current number busy, here you can pick the resources that you have. So for now, I have only one resource, and that's trunk line, so that's what I pick. So if you have more resources, make sure to pick the right number of the right name for the resource here, so that this formulation is written for your resource. Here I have only trunk line, so I don't need to worry about anything. So when you click on the current number busy, the notation is NR, trunk line. That means number of trunk line resources that are busy right now. If you notice NR and MR and all these abbreviations, you can just write them without coming to expression builder window. But you don't need to remember them. You can just come here and just say, I want to pick this, I want to pick that, and then the expression builder window automatically writes down the formula for you. Okay, so I want to check if the number of trunk lines that are busy is less than the number of trunk lines that have been scheduled to work. So current number scheduled. So that's MR. Okay. So this expression checks for me if the number of trunk lines that are currently busy is less than number of trunk lines that have been scheduled to work. If that's the case, that means I still have some trunk lines that are not busy, so I can assign this incoming call to those trunk lines. Okay, and here on the top, I want you guys to pay attention. Like, these are some of the logical expressions that you can use when things are equal, unequal, less than, greater than, less than equal, greater than equal, and or, and so forth, and parentheses and anything. Okay, when things are not equal is this, not equal is this icon. So just know this in case you wanted to write down the formula yourself and don't come to expression builders, that's fine. So you could, if you remember what is NR and what is MR, you can just write this formula here without coming to the expression builder window. That's fine. Okay, that's our two-way condition. It's an expression, that's our condition, and then that's it. So if this condition holds the true, which is this part, it means trunk line is available. Okay. So then, where do we go from there? Make sure to save as we go forward. So the trunk, I need to get a hold of the trunk line. As soon as I find that one trunk line is available and a call has come to the system, first I need to get a hold of the trunk line and then decide what type of call it is and so forth. So for that, there are different ways to do this. But one thing we haven't done before, we know that we want to basically seize that resource. So this entity, incoming call, wants to seize that resource, that trunk line resource, right? So we have done it previously with process, but now we are going to do it with another module, which is seize module. So for that, we have to go to the advanced process panel. And then you see here, there is a seize module. You're going to use that. So just in the advanced process panel, we see more of the building blocks of the modules that we see here. Okay, so for example, in the process, sometimes we have seize, delay, resource, with seize, delay, release, right? So if I go to the advanced process, I see all these three building blocks. I see seize, I see delay, I see release. You will see that sometimes, depending on what we want to do in Arena, we need to use these building blocks instead of a process module. Okay, so that's where you can go in the advanced process template to find these building blocks. So now I want to use the seize. Okay, so I'm going to come here, and as soon as I know I have enough trunk lines in the system, I'm going to seize one. So here I'm going to seize trunk line. And the resource that I'm going to seize is, we already have defined it, trunk line. Okay, and I'm going to seize one. Although there are already 26 of them in the system, the capacity is 26, but for each call that comes to the system, I only need one and do not change anything else. And the resource name, you don't need to create a new name or anything. the name. We already defined the trunk line resource. The name is already here. I always recommend that you guys pick from the menu here as opposed to retyping, because we make mistakes and that causes error. Okay, so I'll press OK. And okay. So one of the reasons that here we only seized a line is that I just want to get a hold of the line, and then later in the model, we are going to decide what type of call it is and what other resources I need, and I impose the delay modules and so forth. So for now, all I want to do is to make sure I can get a hold of a line. So, and this line is going to stay with this entity. This line is going to be seized by this entity for as long as the entity is in the system. And when the entity is done, this call is done and is leaving the system, is going to release this call. So I don't need I don't need to involve basically this trunk line in any delay process or anything. All I have to do is to just seize it when the call comes to the system, so that it's not going to answer any other call, and just release it when I'm going out. And that's exactly what's happening here. So I'm just going to seize one trunk line, and so that it's with this call, and then for the rest of the process, and just release it when I'm done and I'm leaving the system. Make sure to save, guys, as we go forward. And
sorry, Professor.
Go ahead.
Sorry, Professor.
Go ahead.
Yes. Would you mind to explain again why we're using the seize process right here? Thank you.
No worries. So remember here, when the calls come to the system, depending on the type of the call, they are going to be answered by some resources. These are the people who answer technical calls, 2 people, 3 people, 3 people. These are some people that have answer sales calls and so forth. So however, so when the call gets to this point, I'm going to seize these resources and I'm going to impose the delay, because that's the amount of time that it takes for these people to process the call and so forth, right? However, for the lines, I don't need to impose any delay. All I need to do is to, when a call comes to the system, if the line is available, I just need to get a hold of the line. I just need to seize this line and then hold this line with this call for as long as the call is in the system. And then when the call is ready to leave the system, release the call. So the only thing that I need to do with the trunk line resource is to seize it when a call comes to the system, and then this resource, this trunk line, is with the entity for as long as the entity is in the system, and then release this line when the entity is going to leave the system, so that this line is going to be allocated to another incoming calls. So because of that, all I need to do for this resource is just to seize it. When I know one trunk line is available, I'm just going to seize it and hold it for as long as I'm in the system. So I don't need any delay. The delays are going to be imposed when the calls get to the people who are answering technical calls or the sales informations and so forth. Okay.
Okay, thank you.
Sure. Okay. So the other thing I want to do here, I want to increase the number of active calls, because now this call has entered the system. So I want to increase the number of active calls. So let's do that, and I'll tell you. You will see later why we are doing that. But let me. But let's go and do the assign. Use the assign module. Okay. So in these assign modules, I want to count the number of active calls. So I want to increment active call counter. Active call counter. Okay. So I'm going to define. Okay. So previously here, you remember we have defined attribute, right? the time in, and type of the entity, and so forth. But we never defined a variable. So right now, I'm going to define a variable. So I'm going to call this variable as total work in process. Why do I call this work in process? Because this variable is going to count for me how many calls are in the system. They are the ones that have been able to come in. We have had empty lines and they have been able to come in. Okay, so they are there in the system. So this is going to basically count for me my working process. Remember, in the manufacturing system, the working process was the number of items or parts that are already in the system. They are being processed somewhere, or they are in the line somewhere. So now I want to basically count my working process. I know that when we run the simulation, working process is one of the things that the Arena reports for us, but that's after running the simulation and getting the results. If for whatever reason you need to know the working process and use it maybe in some conditions or things, you have to calculate it yourself. Okay, and that's what we want to do here as well. So that's why I'm going to define a variable that is going to count my working process for me. Okay, so then the name of this variable, I'm going to call it total working process. And how I'm going to change the value of this variable. Whenever the simulation gets to this assign module, I'm going to increase the value of this variable by 1, and I'm going to save it in the value of the same variable. So remember, in the past, when we define attributes, the attributes are tags that are associated with the entities. So the attributes are valid with the entities. Wherever they go, these attributes can be used. But variables are not specific to the entities. We may change the value of the variables to go up or down when an entity gets to a point, but variables basically are applicable everywhere in the simulation model. Whenever you call them, you can see their values, you can change their values, and that's fine. Okay, so I'm going to define a variable. I'm going to call it total working process, and this variable is going to calculate my working process in the system for me, because at some point I'm going to use it for some conditions. And how I'm going to calculate the value of this variable? Any time that the simulation gets to this assign module, that means one call has finally entered the system. I'm going to increase the value of this variable by 1, and I'm going to save it in the same variable.
So do you assume the variable is initialized to 0 at first?
Yeah, so that's a good question. When we create a variable, their initial value is always 0. Let's go here, guys. If you click on the variable module, the variable data module in basic processes, here you see this variable that I created right now is automatically created here as well. You see here there is some initial value, and and here if you click, you can define the initial value of this variable. If you do not define any initial value, it's automatically set to 0. Good question.
Okay, thanks.
Then okay. Then after we have a line, so we have seized the line, then we want to do this initial assignment. So we want to decide what type of call we are dealing with. Okay, and this is going to be done by an automatic recording. So I'm not using any resource, any person. As long as I have a line assigned, this is going to be done. So I'm not going to seize another resource. Pay attention. The defining on the type of the call that we are going to have is going to be done by an automatic recording. I'm not using any person or anything. So I don't, and the one resource that I already have seized is the trunk line. So that line will just let me hear these options and then finally direct me to one of these calls. So I'm not going to seize another resource. I already have seized the record, the trunk line, and that's the resource I need. All I need to do is to impose some delay so that this decision is done through this automatic recording. And you know, like for all of us, when we listen to automatic recording, it takes time. So they ask a bunch of questions. If you are this type of customers, press 1, press 2, blah, blah. And finally, they direct us to the right person. And this is going to take time. Uniform point between 0.1 to 0.6 minutes, right? And all I need to do to capture this part is to put a delay module. I don't need to seize anything else, nothing, I'm all set. So I'm going to go back to the simulation, and right here, I'm going to put a delay module. And you know, so the building blocks are here. So I'm going to just put a delay module here. And I'm going to say, okay, initial, okay, let's say call type recording. Let's assume it's a value added time span. It's going to be triangular, no, it's uniform. Uniform 0.1, comma 0.6, and it's in minutes. Okay, so I'm going to call it call type recording delay. It's a value added type of delay, let's assume. And the amount of delay is uniform between 0.1 to 0.6, and it's in minutes. Press OK. Make sure to save. Okay. So since this is the delay, I just brought the delay module. I could do it in another way too. If I would go to and bring a process instead of this delay module, I would bring a process. I'm just going to do it here and delete it. If I would bring a process, I could do that as well, because in the process, I have the option of only delay. I could just do it this way too. Bring a process and just pick delay, because that's the only thing you want to do here with your entity. And then specify here how much delay and what type of distribution and so forth. So either do it using the processes and make sure to pick delay, or do it using the delay module that we get from advanced process template. Both of them are fine. Make sure to save. And then, okay, so now we have spent the time to decide what type of call we have received. Now I'm going to just send the call to the different types that I have. 76% technical, 16% sales, and the rest order status. So for that, I need a decide module. Oops. Just delete if you see any connection or anything, delete it. So here, I'm going to determine the call type. Okay, so that's what I want to do. What type of decision I have to pick here, guys?
It's probably an n-way by
Way
chance.
by chance.
Exactly. It's n-way because we have 3 times. It's n-way by chance because I know the probabilities. So I pick n-way by chance and add. The first one was 76. So you just have to put the percentages. And in the format is numbers between 0 to 100. Don't put, like, if you have 76%, just put 76. Don't put 0.76. Okay. So that's the first one. And then the second one is 16. And I don't need to define the third option. The simulation software automatically calculates the other 8%. Okay. And here, if I click, you see here, so previously I had just one outcome here and one outcome for the else. But now I have two possible exit here, this one, and then this one, and then the else. And the numbers, if you click here, the numbers are the 76% and 16% are written in a text. And I don't know, simulation put them here, but I usually just drag them like close to this sign so that I know the first arrow is for the 76%, the second arrow is for the 16%, and the rest goes to the else. That's just like if I come back to a model like a year later, at least I know what these numbers are for. Okay. That's that. Okay, so at this point, let's go ahead and just connect whatever module we have so far. Make sure to save. Okay. Before I continue further, let me work on two things. One, I want to see, okay, what if we get some calls and some calls come to the system, but we don't have any trunk line available. Remember, this is when the trunk line is available, but what if we don't have any trunk line available? What do we do with those? And then also, let's also capture this part that what if we receive the calls after 6 p.m.? What do we do with those? How to tell the simulation, don't let any new call comes after 6, but still continue working till everyone who is in the system leaves the system. So first, let's do this part. If there is no line in the system available, the call is going to be rejected. And I'm just going to send it to dispose. But before I reject the call, I want to record how many rejected calls I have, because simulation is not going to report that to me automatically. But when I run this simulation, one thing that the manager of this call center has asked me to do is to tell me how many rejected calls you have. Because if he says that we have too many rejected calls, then he may consider hiring some staff so that we can answer most of these calls. Okay, so I want to record that. So for that, I'm going to bring a record module here. I'm going to record rejected call. Oops. Add. So I'm going to have a counter. I'm going to call this counter number of rejected calls. I'm going to call it, and I'm going to increase it by 1. Press OK. Press OK. Connect them.
Professor, you said sorry, I had missed like the very last part because I was trying to stay caught up. You increased rejected count by 1.
Yeah, every time I come through this line, which means I don't have a trunk line, that call is going to be rejected. So I'm going to increase the rejected calls by 1.
Oh, I see. Sorry,
No worries.
I have it right. Thank you.
Yeah. So this is because the manager of the call center has asked us to report in this one day how many calls get rejected, meaning that all the lines are busy. Because if we can report this number to the person, then they can get a sense of maybe we need to hire a couple of more people to answer the calls. Maybe we need to buy more lines and things like that, so that we have less rejected calls. For example, if this is call center of Verizon or AT&T and so forth, this is important. This is the factor that affects customer satisfaction. If I'm calling Verizon and all the times I get rejected and I can't even talk to a person, like I get frustrated at some point, I change my service provider, right? So these are factors, metrics that are important and we want to track them. Okay. And then if the call gets rejected, then we are going to just dispose it. Dispose. Rejected. Okay. Everyone is good so far? Everyone is with me? Okay. Now let's take care of this part regarding to the arrival. So what I want to do here, first, let's go to the variables. I'll explain in a little bit why, but let's go to the variable and define two variables. The first variable is going to be max call. Okay. And that's the variable. So first, okay, the initial value is 0. And then the other variable is going to be calls per arrival. Okay. So okay, so to keep these variables, what I want to do here is that I want to tell somehow to the simulation that at times, give me 1 second, let me close the door. So I want to tell the simulation that at some points, the number of entities that are coming to the system is going to stop. And so we are not going to get any other entity in the system. And that happens at time 600. Okay. So let's see how we are going to do that. So I'm going to create another create module here. Most of the times when we put a create module, it's because we want to create something physical, like a call, the parts, like we know those entities, we have a sense for those entities. But here we are going to create a create module because we want to bring some entities that are entering the system only to activate some modules that we are going to put here at some specific time. They have no other purpose. And so these entities that are going to basically be brought to the system are some virtual entities or some dummy entities. We don't really need them. We just bring them to the simulation because we want at some point this module gets activated, and then it's going to activate some other modules that we have put here. So let's see what happens here. So at this point, I want to create a cutoff entity. So create arrival of, basically. Create arrival of cutoff entity. Okay. So, and the name of this entity, I'm going to put cutoff entity. And the time between arrival is going to be constant. I'm going to put the value of a very big number, 999,999. how many entity of this type I want to come to the system, 1, and for the unit also pick minute. And the max arrival, or also I put as 1, and the first time that this is going to be happen is at minute 600. Okay, and why did I put minute 600? Because 8 a.m. to 6 p.m. is the number of hours. If you multiply it by 60 minutes, that's 600. So that's 10 hours, 10 working hours. So if you start running the simulation, that would be at minute 600. So what do I want to do after this? After at time, the first time this entity is going to be generated, it will be at minute 600 when we are at 6 p.m., right? And I want only one of these entities, and these entities to come to the system one by one, and I only need one of them to be generated. And because of that, I don't care really about the inter-arrival time that I put here. That's why I just put a big number, because it doesn't matter. You can put 0, you can put any number that you want here. This number is not going to be used at all, because for this create module, I said that I want only one entity, and this arrival is going to happen at time 600. That's 6 p.m. when we are going to close the door. Okay, so let's just specify that here, and just make sure to change the unit of time to minutes, so that this is 600 minutes. And let's press that. And what do we want to happen afterward? At time 600, when this dummy entity enters, we want this assign module to get activated.
Professor?
Go ahead.
Why won't the schedule module work, or like having a schedule for the chunk time?
That's one way, but here this is another way, and we just want to learn another way to do this. But
okay, sounds good. Thank you.
Okay, so what do we want to happen in this assign module? So here I'm going to call assign cutoff variable. And what I'm going to do here is that for the variable max call, I'm going to pick it as 1. And let's define one more variable. That's going to be variable of calls per arrival, and I'm going to assign the value of 0. I'll tell you in a second why. So in this assign module, I put the value of max call as 1 and the value of call per arrival as 0, 0, 0. The calls per arrival as 0, 0, 0. Okay. So let's go back to the initial create module that we had. So here I have entities per arrival. Initially I put as 1, right? And here, instead of entity per arrivals, I want to use this variable that I calculated. So calls per, so I want to put the calls per arrival. Okay. So instead of entity per arrival, I'm going to put calls per arrival. And then for the other place, when we identify max arrivals that I have put infinity right now, I'm going to put the other variable, which is max. Okay. So then in our original create module, when the calls come to the system, I'm going to define the entities per arrival by calls per arrival variable that I already have defined, and max arrival by max calls. So tell me that before we get to 6 p.m., what is the value for calls per arrival? During the day, the calls are coming to the system. What is
It's 1.
Is 1, okay? So if it's 1, then I go back to the variable, and for calls per arrival, I'm going to click on the initial and make sure the initial value is 1. Okay, so do that, save. And then how about max calls? So we run the simulation during the day. Do I need to put any limit on the max calls? Like what is the potential value for the max calls? So I can go back to the variable max calls and just say for the initial, let's say I'm going to put a big number, 999,999. So let's say I know that within 1 day, definitely I'm not going to get 1 million customers, right? So just put a big number so that it doesn't limit your system. Okay, make sure to say. So then I have defined 2 variables, calls per arrival, initial value, and then max calls that are going to be received by the system, big number, 999,999. And here for the original create module, I set the entities per arrival instead of 1 that I entered initially. I'm going to just use calls per arrival, which already has the value of 1. And for max arrivals, instead of infinity that it was, I'm going to just put max call variables, which already have value of 1 million. And I'm pretty sure that in 1 day from 8 a.m. to 6 p.m., I'm not going to get really that number customers. So I know the value that I put for the max arrival is not the limiting factor for my system. Okay, so that's all good till we get to 6 p.m. As soon as we get to the 6 p.m., then this part of the simulation gets activated. And a dummy entity, a virtual entity comes in right at time 600 minutes, and I only need 1 of those, so it happens only once. As soon as that happens, this assign module gets activated. So then I'm going to change the value of the variable max arrival to 1. So why do I do that? Because if the value of the variable max arrival is 1, when these entities are created, the simulation looks at this part. It says, have I created enough to meet the max arrivals that was requested? And for sure, by time 600, at least we know 1 customer has entered the system, right? So for sure, the system has had 1 call entering the system. And max arrival, then it gets value of 1. This means we already have met this limit, and the simulation is not going to create any new entity after time 600. Okay, so when I change, remember the value of the max call, initially I set it to 999,999, right? That's the initial value, and that's the one that is used throughout the whole day. As soon as I reach 6 p.m., I'm going to use this assign module to change the value of the variable max call to 1. As soon as that happens, then the 1 is basically what is in this variable. So when the simulation wants to create another call in the system after time 600 minutes, simulation is going to generate another call. And then for that, simulation is going to look at this condition. It says, oh, max arrival is 1. And for sure, I already have created 1 entity in the system from 8 a.m. to 6 p.m. So if the max arrival is 1, then I'm not going to create any new entity. Okay, so that's basically how we are going to stop the simulation after time 6 p.m., after 600 minutes, to not create any new calls in the system. Okay, so that's that. And then one other thing that we do here is in addition to changing the max call to 1, one other thing that I did is that I changed call per arrival to 0. So why did I do that? Calls per arrival to 0. Remember here, I used the calls per arrival here, and the initial value of calls per arrival is 1. Entities calls come to the system one by one, and that's perfect. What happens in the simulation in Arena is that when an entity comes to the system, let's assume an entity comes to the system at minute 595, okay? That entity comes to the system, great. We are before 600 minutes, the entity comes to the system, no problem. The Arena, as soon as that entity comes to the system, decides on the time that the next entity comes to the system. So the Arena already is going to, so let's say at time 595 that the last entity has come to the system, Arena automatically decides that 10 minutes from this point of time, I'm going to bring another entity, another call to the system. This is automatically automatically done in Arena. That's always happens. As soon as one entity arrives, the time of the arrival of the other entity has automatically been calculated. So this is something that Arena already knows, that at 10 minutes later, at minutes 605, a new entity is going to come to the system. Then what should we do? The reason that we change the calls per arrival to 0 is that when Arena is going to execute that code, the calls per arrival has changed to 0. So Arena is going to generate an entity, but 0 entity. So the generate command behind the scene in Arena is going to work, but it's going to generate 0 entity. And that's why here I not only change the value of max call to 1, such that after we pass minute 600, I'm not going to create another call, any other new call in the system. However, for those calls that were set to be created before we reach 600, at minute 595, I don't know, 580, whatever, and those are going to be, those automatically have been set to be created after minute 600, I'm going to change call per arrival to 0, such that when those entities are going to be created, basically 0 entity is going to be created. And that will automatically change the value of these two variables for us right at time 600, and that will guarantee that after we pass minute 600 or 6 p.m., no call is going to come to the system. And the advantage is that we can still run the simulation. You may say, why don't we stop the simulation at minute 600? Yeah, if I stop the simulation at minute 600, that is not going to let any other new entity comes to the system after minute 600. However, what about those calls that are already in the system? They are waiting in a line or somewhere. Those will not get processed either. So I want to be able to run my simulation past 600 minutes. However, I don't want to let any new entity, any new call comes to the system. That's why I'm going to put these additional modules and these dummy entities and these assignment modules such that it can change the value of these two variables for me at time 600 so that I don't get any new entity in the system. However, I can still run the simulation and just make sure I process the calls that are already in the system. And just make sure, can I just leave this part as is? Do I need anything else?
Professor?
First answer my question and then ask extra.
You can ask, please.
Go ahead.
I'm sorry. Are you saying that if there is no arrivals coming come into this system, the process will stop automatically?
No. Because the initial value for calls per arrival is 1, and the initial value for max call is like a 1 million. So basically, for as long as for the 6 hours or for as long as I run the simulation, the entities are going to come to the system. the only way I can tell the simulation that no other entities will come to the system is that I tell the simulation that I'm done. This max
Okay.
is 1. And
Yes, I'm curious why don't we just set the max call to 0 directly so that there is no arrivals after 600 minutes.
max call, so you mean here instead of 1?
Yeah, you can set it to 0, so you don't have to set.
That's error, because for sure between 8 to 6 p.m. some people have arrived, right?
Yes.
So if I change the max call to 1, that means, oh, some entities have already entered the system. So as if I already have met this condition, I don't need to create any additional entity. So that's going to take care of that. So even if at this point you change it to 0, I think you may get error for the max call. Well, we can try later, but it doesn't change anything. So we need to anyway change the value of this variable at time 600. And when you put it 1, that means, yeah, some entities have come to the system. We already have met this condition. I don't need to generate any other entity, but still I have to somehow do something for the entity that was scheduled to be generated in this system before minute 600 and is going to come to the simulation after minute 600. So that's why I put calls per arrival to 0, so that then that entity that was scheduled before is going to arrive to the system, let's say at minute 6:10, then the calls per arrival is 0. So basically no entity would come to the system. Do I answer your question?
Okay, I see. Thank you.
Sure. This was my alarm to make sure my computer doesn't go out of battery. Okay, my question from you guys was that let's assume I had done everything else in the model and I would run the simulation. Is this part complete? Do I need to add anything else? An entity has come to the system. This module has been activated. I have assigned these variables. What else? Can I just leave this entity on the floor?
Dispose the entity.
Exactly. Remember, we always need to do something with the entities. Like when this entity comes out, although it's a virtual entity, whatever, I still need to dispose it and get rid of it. I can't just leave it in the simulation model, otherwise you get error. Dispose. Okay, dispose code of entity, press save. And okay, so before we continue with the rest of the model, let me just talk about 2 points. One is that what we did just now in terms of not letting any new entity to come to the system after minute 600, however, making sure that we still continue the work and we still let the simulation to continue till we basically are done with processing every call in the system and then stop the simulation. That's something that we do for systems that we call as terminating systems. So I want you guys to remember this term because it's an important term. So what are the terminating systems? Terminating systems are like this call center, like a supermarket, barber shop, anything like that, where for terminating system, there are a couple of conditions. One, the initial condition that the system starts working at is fixed. So for example, in a call center, always every day we start with 0 call in the system. In a supermarket, always every day we start with 0 customer in the system. In a barber shop, always every day we start with 0 customers in the system. Okay, it doesn't have to be necessarily 0, but it's the same every time we want to start the system. These initial conditions are the same, and when the system ends, the terminal conditions are the same as well. So end the system when we pass 6 p.m. and we have processed all the customers. If we are working in a barber shop or let's say supermarket, the same situation. close the doors at this specific hour. Do not let any new customer to comes in. However, continue the work till everyone in the system gets the service and leaves. So the initial condition and the terminal conditions are the same. And when we model these type of systems, we put them in the category of terminating systems. And the reason is that the termination of the system, or about this, for example, at a specific day or after specific hours, are clear. So for these type of systems, if you want to, for example, see how a call center is working overall in each day, I'm going to use replications. I'm going to use replications to see for how many times I have to run this simulation. So for example, we have developed a model that can simulate for me how this call center is working in a day, right? From 8 a.m. to 6 p.m. And what if I want to get a sense of number of customers that are, or calls that are made to the system, number of calls that are rejected, and number of calls of this type or that type. I can't just run the simulation for once and just report this number, because that's only one day. So for me to be able to report some numbers that make sense, I have to run this simulation model multiple times. And if you guys go to the run, I don't want to run, I just want to show it to you. If you go to run setup, you see here number of replications. So far we have left it as 1 and we haven't changed it. But later we get to the point that we are going to decide how many replications are needed, or how many times I have to run the simulation of this call center, such that I can rely on the numbers that I'm reporting in terms of any statistics that you are monitoring. Okay, so we are going to talk about that later in one whole session. Is talk about the how many replications and what to report and how to report and so forth. But anyway, what I want you guys to know is the term terminating system. The other opposing term is non-terminating system or steady state systems. We are actually going to learn those as well in this class. Non-terminating systems are the ones that do not have any specific terminating condition. So for example, if we modeling a manufacturing process, there is no specific terminating condition for the system. When we reach 5 p.m., for example, we just close the door. Wherever we are, we stop, we close the door, we go. When we come back tomorrow, then we start from where we left off the day before, right? And this is just going to continue every day. So basically, I can just run the simulation continuously. If I want to run the simulation for a week, I can just run it continuously for 40 hours, 5 days a week, each day 8 hours. I can just run it continuously for 40 hours. And that gives me what happens in a week, because yeah, the workers go home and sleep and blah, blah, but the amount of entries that are in the system and everything works basically similarly. Every day I start from where I left off the day before and so forth. So basically, I can just run this simulation continuously for 40 hours. Those are the systems that we call as non-terminating system or steady state systems. And again, for those systems also, it's important to know how long we have to run the system so that these numbers make sense and blah, blah. So we actually get to those and we run those and we do all the analysis on those as well. But I want to make sure you guys know these terms, terminating system and non-terminating systems or steady-state systems, and what are the differences between the two. Systems around us fall under both categories. So some of them, like supermarkets, mainly service industry, a bank, a call center, so forth, they are in the terminating system category. Most of the manufacturing processes are in the non-terminating system category, and for each one of them, for you to be able to report reliable numbers and so forth, we also have to learn how to run the simulation. So far, what we have learned mostly is how to develop the simulation, but what we are going to learn later more is that what should be the setup of running the simulation so that I can report reliable numbers. Okay, so that's one. The other one thing I wanted to mention is that here we use this method to take care of the terminating system thing, but another way that I will teach you guys later is that using the schedule to take care of no entity coming to the system after 6 p.m. Doing some schedule module. We know the schedules and things, but we haven't learned exactly how we can use the schedules for the arrival. We have examples on that later. We will work on it in another example, and when we get there, I will tell you how we can use that to capture, to model the whole terminating system concept in this model. Okay, so that too. So let's continue. Make sure to save your model, guys. Okay, so now we have reached the point that we want to determine our call type. So we know it's a, so okay, no, sorry. We want to assign the call type. So here we are. We want to decide what type of call we are dealing with. Tech support, a sales, or an order status. And we know this is going to happen through an automatic recording, and it's going to take this much time. I'm not going to seize any additional resource for that. All I have to do is to impose some delay to the entities so that I can capture this part in the simulation model. Okay, so sorry guys, my bad. We already did that part. So the calls came to the center. We seized the trunk line. We counted the number of calls that are in the system. This is the delay part. We already did that part. So this is the time that we do not seize any record. So we just do the delay to do this assignment. We did that. And then we decided what 76% are going to be technical, 16% are going to be sales, and other 8% are going to be order status. Now let's deal with the technical calls. So the first thing that I want to do is to use assign module. So we are working on the technical calls. Okay, so I'm going to use an assign module, and here I'm going to assign technical calls, entity type, I'll tell you why, what does it mean. So as soon as I found a call is technical with 76%, I'm going to run this assign module. And here I'm going to do two things. One, if you click on this type part, remember previously we had attribute, we also learned to define variables and so forth. What I want to do right now is to define something, define the entity type. Like when a call comes in, I want to specify that this is a technical call type, or a sales call type, or an order status call type. So there are basically two ways we can do that. We can define an attribute. So this can be a tag. And then here in this attribute, we can say, oh, the name of this attribute is entity type. Okay, so that's one. But what we are going to do here is that if you click on the type, here you see you have two options. So one is entity type. If I click on the entity type, here it tells me basically define a name for this entity. So I'm going to call it tech call. Okay, so these are technical call entities. So what I did basically here is that I assigned the so-called entity type to this entity. All of them, when they come to the system, they are calls. But here I'm going to assign a new name, and I'm going to assign a new type to this call. So the advantage of this is that when I run the simulation is going to report the results for technical calls separately. Otherwise, if I don't define entity type, simulation are going to report the results just over the call entities. But here, when I define entity type, simulation is going to report the results for the technical call entities separately, and that's good because it helps me to see some recording for technical calls, how many technical calls I received, how much they waited in the line, and so forth. The other things that I'm going to do is that I'm going also to assign an entity picture to these entities. And why I want to assign an entity picture just for the sake of animation, such that when these calls come to the system, I want to just show the technical calls with a different icon. And so maybe I pick picture yellow ball. Okay, so that's just for the sake of animation. You are absolutely fine if you don't want to do that, but that's for the sake of learning and animation, such that when we run the animation technical calls, after they pass this decide module, technical calls are going to be shown by yellow balls in the rest of the system. Okay, so as soon as I found the entity is technical with the chance of 76%, I run this assign module. When I assign a new icon to the entity, and I'm also going to give them a separate entity time. I'm going to call them technical call entity, and you will see the advantage of this is that when I run the simulation, I see the results for this entity type separately. Make sure to connect the 76% to this assign module. So this, make sure just to connect 76%, don't wrongly connect 16%, okay? So that happens if the calls are technical, that's 76%. And then after that, after the calls, after I gave a different picture and a different entity type to technical calls, remember this happens. Using the recordings, automatic recordings, it's going to take something between 0.1 to 0.5 minutes for us to ask a bunch of other questions and decide if the call is type 1 or type 2 or type 3. Okay, I don't need any person to do this. This is just automatic recording. As long as I have seized a trunk line, which I have, I'm going to do this. And all I need to be able to capture it in the simulation is a delay module. That's all I need. I don't need to seize any other resource, nothing. So to be able to capture this part, then I'm going to put another delay module here. So this is technical call, product type, so delay. So this is the time that automatic recording decides on the technical call, the type of the product. It's uniform between 0.1 to 0.5, and make sure it's minute, and make sure it's not crazy important, but I define it as a value added. So I change these things so that you know these are the places you can define if it's value added, non-value added in real world simulation, in your jobs later. These are the things you can play with and they affect your results. Okay, so in this delay module, I'm just going to impose a delay to the entity. I'm not going to seize any resource, nothing. Make sure to save. And then as soon as we are done asking the questions to find out what type of product they have question with, I'm going to decide on the type of product. And that's 25% product 1, 34 product 2, and the rest product 3. So for that, I need basic processes again. I need a decide module. Determine product type. I'm going to pick obviously n-way by chance because 25% are product 1, 34% are product 2, and the rest are product 3. Okay. And again, here you see, I usually click on this and just move it next to these little arrows so that I know the first arrow is 25% and the second arrow has a chance of 34%. And the rest goes into the else. And make sure also we connect these modules as we go forward. Make sure to save. Okay. Now, the question is, the tech support question is related to product 1. All these processing times, no matter it's product 1 or product 2 or product 3, is going to take triangular distribution 3, 6, 18 minutes. Okay. And we also know how many resources we have how many agents we have to can answer questions related to product 1, how many agents we have to answer questions related to product 2 and product 3. So for that, what do I need to put here, guys? A delay only, or a cease delay release? Like, what do you think I have to put here to capture the processing time of the calls related to technical support for product 1? Should I put a process or just delay?
Wouldn't you do process, because you have for each product 1, product 2, product 3, you have I think that's 2 reps helping, 3 reps helping, and 3 reps helping for product 3.
The most important thing, yeah. So the most important thing here is that I have to seize these resources, right? I have to get a hold of them. So far, the only resource I have seized is a trunk line. That's the only resource I have seized so far. When I want to answer the questions related to this product, I have to seize again another resource. That resource is these technical people. And then I also have to hold this resource for some time to perform the task, and then I have to release them so that they can answer another call. So I do all 3. I seize the resource, these technical staff people, I do the delay for the time that I'm asking the question, and then I release them. And because I do all 3 operations, then I'm just going to simply use a process module. Good. So in this one, I want to process product 1 call, technical call. I'm going to just copy it because I'm going to just type it for the other processes. So here, in this process, I'm going to process product 1 technical calls, and this is a cease delay release. I'm going to, have I already defined the resource for processing the technical support calls? Have we done that? You said what? Can you repeat?
We haven't.
We have not, that's true. We have not, so I'm just going to type here. That, I'm going to call it tech 1. That's technical support for product 1. And how many of those people I need for each call?
Just 1.
I just need 1. And in terms of the processing time is this much, and I can just go ahead and define that here in this part. That's easy. We all have done that. That's fine. But just for the sake of learning, let's press OK. I'm not going to change anything here. Let's just press OK. I'm going to go into the advanced process. And here at the bottom, you see expression. Just click on the expression. And here, just click so that we get a new row. And let's open the window. So in this process, so here we just want to learn, again, just for the sake of learning. As I told you, you could just write the process time over there, that's fine. So just for the sake of learning, I'm going to use define an expression. In this expression, I'm going to put the processing time and then use that expression in this module to define the processing time. So I'm going to call this as tech support process time. And the value I'm going to assign here is triangular mean 3618. parentheses. Okay, don't change anything else. So I define an expression, I call it tech support process time, and I just define the value of this expression. So anytime in the simulation, when we get to this expression, a random number from this distribution is going to be generated. Okay. So now I have this expression. Now I come back to this process module, and here on the delay type, instead of just triangular and everything, I'm going to define as expression, and I have to put the name of this expression, and the name of this expression is not listed here. If I open this, I don't see the name of the expression, and I usually don't like to type because I know I forget. So I go back, open the expression, just copy the name so that we don't forget it. Copy the name, come back to the process module, pick expression, and here as the name of the expression, just put that name and make sure you change it to minutes and its value added. Okay, so for the time of processing a call of technical support call related to product 1, instead of just picking triangular and just defining the minimum mode maximum, I use an expression to be able to do that. So for that, I went to the expression module, I defined that expression, which could be something as complex as you can imagine, add a bunch of things, divide, I don't know. Define that expression, and when you come here, when you pick expression, just put the name of that expression. Every time the simulation gets to this line, it's just going to run this expression and give you the number. The advantage of using expression is that if you have a mathematical formula that you use at multiple places in the model, then instead of just repeating that mathematical formula like 5 times, you can just define it once as an expression and just call that expression name every time you want to run that mathematical formula in your model. So that's the point of the expression. So you can write everything here, but again, if it's just once in the simulation model, fine, no worries. If it's multiple times in the simulation model as opposed to repeating, which causes mistakes and errors and things like that, you can define the expression once and just call the expression name and just go forward. So let's do that. Let's see, someone had a question in the chat. Okay. And so let's first of all, make sure to save. So this was the processing time for product 1. I'm going to do the same for product 2. First, I'm going to copy this name and then process product 2 tech call. This is going to be a seize delay release. The resource I'm going to seize, I'm going to call it tech 2. That means technical support for product 2. I just need 1% per call. And for the delay, for the processing time, instead of just repeating triangular, 6, blah, 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 I'm just going to say expression, and I'm just going to type the name of the expression. Okay, so just put again the name of the expression. So that's fine. And then lastly, I'm going to bring another processes for processing time of product 3. So that's process product 3 technical calls. That's going to be seize delay release. The resource, I'm going to call it tech 3, meaning people for tech 3. I only need 1% to answer a call who has a question regarding product 3. and the delay time is coming from an expression, and that expression is what I defined. The name of the expression is here. Okay. Make sure to save. Make sure to connect 25% to product 1, 34% to product 2, and else to product 3. Okay, let me end minutes. Okay, so yeah, thank you for reminding me. The processing time, make sure it's minute, guys. Minute as well. So the processing time for all these processes, we use the expression, but make sure the processing time is minute. Okay. Then what do we need to do next? Okay, so this was all related to technical calls. And then I need now to take care of the sales related calls, this other 16% that I have here. This was the 76% technical calls. Then how about this 16% of sales calls? So for that also, I'm going to start by using an assign module. With this assign module, I want to assign sales calls, entity type, and picture. So the first thing, I'm going to assign an entity type to this entity. I'm going to call it sales calls entity. And I'm going to also assign an entity picture, because when I run the simulation, I want to just, for the sake of animation, I just want to show the sales calls with a different icon. So we pick the yellow ball for the technical call. So let's pick the red ball for a sales call. Okay. So just I assign an entity type, an entity picture, mainly for the sake of simulation, and also because when I assign entity type, when the simulation generates the results, I can see the results for this specific entity. Although all of them that came to the system are calls, when I assign entity type, simulation will generate results for that specific entity type I have defined. Make sure to save. And for the cells, everything was easy. As soon as we find out they are cells, we're just going to process them, and this is the processing time. Okay. So for that, what do I need? Just the delay or the process? What do you recommend? A delay module or a process module?
Could be a process module.
Yeah, a process module, because I need to seize a new resource. Those are these people who answer calls related to sales. I need to seize them, and then I need to hold them, delay them for this amount of time, and then I need to release them so that they can answer another call. So it's all there. So I can just use process module, and this is going to be process sales calls, and it's going to be sys delay release, and the resource I don't have that resource because I never define any sales rep and sales person, let's say. And I need just one person, one salesperson to answer a call. And the processing time for the sales calls is triangular 45:45 minutes, 4:45 value added and everything. Okay, so this is for processing a sales call. The resource is the salesperson. I just need one of those to be able to process a call. And the processing time is triangular 45:45 and it's in minutes. Don't forget to change into minutes. Save. Make sure to connect them. So these cells are related to this 16%. Okay, make sure to save. And is everyone good? Are you behind? Are you with me? Are you guys okay? Is this speak okay? No one said.
Yeah, it's okay.
Yes, Professor.
Yeah.
Usually if we were face-to-face, I would walk in class, I would see how everyone is doing, should I slow down or not, but I'm pretty much teaching in blind. Anyway, so now let's deal with the other calls that are order status calls. So those are the else part. And for those, let's again use an assign module so that we can assign a new entity type, assign order calls. So first, I want to assign an entity type to these calls. I'm going to call it order status entity. And that way, when the simulation runs, I can get results for this specific entity. I'm going to also assign a different picture just for the sake of animation so that I can just see them differently in the animation and I can make it get a better sense. So I already used the red ball and yellow ball. So let me use green ball for this one. Okay. So that's the assign module for the earth. Press OK and make sure to connect the else to this assign module. So now I'm here order status. For order status, I'm not going to use any person. I'm using the automatic recording to basically help the calls to find out the status of the order. And this is the amount of time. So to be able to capture this, what do I need to put here? A process or a delay?
A delay. Delay.
A delay because I don't need to seize any other resource. All I need to do is to just hold the entity here for this amount of time. So all I need is a delay. For that, I'm going to go to advanced process, delay, drag and drop. Let's say it's value added, delay time is uniform 0.1, 0.5, I believe. and the unit of time is in minutes. Oops. Make sure to save, guys. And okay. So here, remember the calls that are order status? We said 15% of them have some sales questions. So after they're done, they have to go get answered by the salespeople. 85% of them have no sales question and leave the system. Okay. So let's see how we are going to capture that one. So after we answer the order status, then I need to put a decide module to see if they need additional sales question or not. So here I say no salesperson required. So I'm going to obviously pick a two-way by chance because either I need a salesperson or I do not need a salesperson. I do not need a salesperson with 85% chance. So I said no salesperson required. Okay, so that when this one is true, that's 85%. Okay, 85% of them, no, they don't need any salesperson, they are done. So press OK. So the true is corresponding to that 85% that do not need additional sales representative. The false is related to those that need to talk to salespeople. So now let's take care of that. One thing also that we know here is that people who are order status and then they say, oh, I need also to talk to a salesperson, have lower priority compared to the calls that are defined as sales originally. Okay, so then although these calls, these entities are going to stay in the same line and be answered with one of these salespeople, but I want them to have lower priority. As long as I have calls that are defined as sales calls originally, those are the ones that are going to be answered first. Then I will take care of these lower priority calls. So to be able to do that, I have to assign the priority to this call. So let's use an assign module. I'm going to put the rest here. So basically, I'm going to the rest here. So in this assign module, I'm going to assign order status call priority. Okay, so how do you think I have to do that? With everything you know so far, how do you think I can potentially give a priority to these calls? Can you tell me what are some of the techniques that we have learned so far that potentially we can use for this to assign a priority thing to the entities? Can I use attributes? Give a tag to these entities, and in that tag, I specify their priorities. Okay, a couple of you are yes in the chat. Okay, so that's what we are going to do. So I'm going to define a new entity, a new attribute. I'm going to call it as sales call priority. Okay, and I'm going to give the value of 1 to this attribute for these entities. So this is attribute, right? This is a tag for the entities. When I define an attribute, all the attributes, all the entities in the system are going to get this tag. Okay, so that's for sure. Now, for these order status calls that need to talk to salespeople, I'm going to save the value of 1, let's say, in this tag. Okay, so I'm going to save the value of 1 in this tag. Can you tell me for the other entities for which I have not changed the value of the tag, what is the default value? Do you not know? So here I assign an attribute, and in this attribute, I put the, I'm going to show the priority of these entities. And let's say here I just put for the calls, for the order status calls that need to talk to a salesperson, I gave them for this tag, I gave them value of 1. So for other entities, let's say the technical calls or the sales calls or things for which I have not changed the value of the tag, what is the default value? Do you know?
I think it's 2.
Another guess?
I think it is 2 because it says medium somewhere.
No. Do you want to try one more thing?
0.
0. For all the variables and all the attributes that we define, the initial value is 0 unless we change them. By default, their initial value is always 0 unless we change them. Okay? So for all other entities, for the sales and call entities, for the technical call entities, the value of their priority tag is 0. The value of the order status calls tag for the priority is 1 because that's the one I assign here. And in a second, I tell you why assign 1 to this and 0 to the other and how we can change those values and what do they mean, okay? But just know that by default, the initial value of every attribute and every variable we define in a model is 0 unless we change those initial values. Make sure to save. And okay. Now, this order status calls and now has to go and wait in the same line with the calls that need sales information to be answered by salespeople. So the very first thing that is going to happen here is that first I have to seize a salesperson. So for this call to be answered, first I have to get a hold of a salesperson. Okay, so let's do that. To be able to do that, if I want to just seize a salesperson, I'm going to go to the advanced process module, and click on the seize and just seize the resource. So here I'm going to say seize order status seizes a sales person. Okay, so let's assume this is a value added. So here I just want to get a hold of the salesperson because they are the ones that will have to answer me. So the resource that I want to get a hold of is a salesperson. I already have defined this resource. You're not going to define a new resource. The salesperson is a resource that I already defined when I wanted to process the sales cards. So I'm going to use the same resource and I just need one of them and that's it. Do not define a new resource here. I strongly recommend that do not type the name of the resource. Always pick from this menu. And here when you open, you see the resource salesperson is already there. So just pick that. Okay. So this seize is going to basically try to get a hold of a salesperson. However, one thing that I want you guys to pay attention to, and this is because we wanna implement the priority concept, is that I want this person, this call, to stay in the same line as the sales call. So this order status call, I want it to go and stay in the same line as the sales calls say. And then each one of them also has a priority tag, and then this person just picks the call that has higher priority. So if I want these order status calls go and stay in the same line, I'm going here on the queue name, I'm going to pick process sales calls. So because that's the name of the queue that was assigned to this process. So remember, this is the process of processing of the sales calls, right? So the name of the queue that is automatically created for this process is the same name as the process sales calls dot queue. So that's the queue for this process. And for these order status calls, if they need additional sales question, I want them to go and stand on the same line with the sales order calls. So they are going to use this resource and they're going to stay in the same line as process sales calls. So that's why I changed the name of the queue. Otherwise, simulation would automatically generate a new queue and would call it order status call scissors blah blah dot queue. Okay, so press OK. And okay, I seize the resource, I get a hold of a salesperson, then I need to get processed, okay? And the processing time, when they have sales question has the same value as if they just have an order status. So if they need additional sales question, the time that they spend with the salesperson is triangular 2, 3, 4. Okay, so that's the time that they are going to. That's the time that they are going to seize this resource. So then I need to put a delay module here. And this delay module is going to delay for order send call conversation with sales agents. This is a value added. The delay time is triangular 2, 3, 4. And the unit of time is in minutes. Okay, so this delay is basically the time that this person, this call, needs to talk to the salesperson, the additional question, and the time that it takes is triangular 2, 3, 4, and that's what I put here, and it's in minutes, and that's it. And then after I'm done, after this call is done, I'm going to release the resource. And here I'm going to release the sales call. I'm going to release the salesperson that I'm talking to, right? So I got a hold of the salesperson. I asked my question and I'm now going to release it. The resource that I want to release is the salesperson, and that's it. Make sure to connect. Okay, so also let me connect the top ones too. Okay. So for the order status calls, they came, they got answered by the automatic recording. So it's just a delay. I don't seize any resource. I don't release any resource. It's just a delay. And then 15% of them also need to talk to a salesperson when they come to before they go and wait in the same line to be answered by the salespeople. I assign a priority to them. To do that, I use the attribute concept. I give them a tag. I call them sales call priority, and I give the value 1 to this tag. For those other entities that for which I have not changed the value of this tag, the initial value of the tag is 0. Okay, and I gave them the tag of 1, and then now they are going to seize the resource as they are going to seize the salesperson. I'm going to make sure they are using the same line as the same queue as the sales calls that came to the system originally. So that's why we changed the name of the queue here. And they just get a hold of a salesperson. So I did not define any new resource. The resource is the salesperson that I already have defined. And then the time is triangular 2, 3, 4 for processing. So that's the delay. And then when I'm done, I'm going to release the resource, the salesperson. Okay. You may ask why I just put a process and just say seize, release, seize, delay, release. Okay, so you may ask, okay, why instead of just putting a seize and delay and release separately, I just don't go to the basic process and just put a process and just say, oh, this is what happens here. If we do that here, for example, if we use process, it's not going to let us to pick the queue name. So if I put a process and I want to say that, oh, they are waiting in the same line to get processed, I don't have any option for picking the name of the queue here. So that's why I'm not using the seize, delay, release that exists in the process module, although it has everything that I need. So I have to go, I have to do a little work and write the seize and delay and release separately, because when I put the seize modules separately here, it does let me to either define a new line or a new queue, or pick one of the queues that are already in the system. And since I want these calls to go to the same queue that the other sales calls are waiting, I'm going to use the same queue as sales calls. So that's why I need to be able to change the value of the queue. And that's why I use separate seize, delay, release modules. Okay, so now, yes, these calls, these order status calls that need to talk to a tech support are going to wait in the same line as the sales, as the calls that are originally sales related calls. But how does the simulation know to give higher priority to these sales calls and lower priority to the order status calls? How does the simulation know that part?
You can assign an attribute, and then which
already have done, we assigned the attribute, which is call priority, and we gave the value of 1 for the order status calls and the default value of 0 for their sales calls. So we already have done that part. Then the question is that how to tell the simulation in that queue when all these calls are waiting to look at this attribute and attribute value and pick that as priority. To be able to do that, we have to go to the queue data module. So if you go to the basic processes, there is queue, click on that data module. So here we see all the queues we have defined so far. So for the process sales call queue, which is this queue that the originally sales calls and this order status calls went to, you see the type is first in, first out. That's the queuing rule, right? For all the queues, the original queuing rule is first in, first out. That means the first person who is in the queue is the first person that is going to go out and get the service. What are some other possible values? Last in, first out, which means the last person in the queue is going to be the first person that is going to get the service. Similar to, there are not many systems like that, but what we see in an elevator is pretty much like that. So the last person who gets in the elevator is pretty much the first person who's going to go out. Or sometimes these queuing rules can be based on attribute values. So we can say, who is the person who is going to go get the service first? The person with lowest attribute value or the person with highest attribute value? Depending on the value of the attributes that you have given to these entities, you can pick any one of these rules. So here, given the fact that the attribute priority has value of 1 for order status calls and the default value of 0 for the sales calls, what rule should I pick? Lower attribute value or highest attribute value?
Lowest attribute value.
Lowest attribute value, because the call that I want to have higher priority and leave, sorry, these are the alarms because I'm not close to the charger, so I just want to make sure my laptop doesn't run out of charge, so I put alarms so that I check my charger. Anyway, so I picked the lowest attribute value rule because I want the calls that are in this queue, the calls with the lowest attribute value, to have higher priority, and that's why I do it here. And I know here, this is how we define the attribute value in this system. I just happen to give the value of 1 to the attribute value for the order status calls and value of 0 default value for the sales process calls. So I'm just picking lowest attribute value because I want them to have highest priority. But if you are going to change the value of your attribute and make sure the sales calls have higher attribute, that's fine, just pick the right rule. So find out what are the values you have given to your attribute corresponding to those, pick the right rule. Here for me, lowest attribute value will work. And what is the attribute that I'm going to look at? I'm going to look at sales call priority. So here just click and pick the attribute name, because the simulation otherwise doesn't know. If our entities have like 10 attributes, how does the simulation know which attribute it should look at? So pick the rule lowest attribute value in this case because of the type of values I gave to attribute. And the attribute that I want you to look at is sales call attribute. And one very, very important thing, if you don't do that, you will get error. One of the things that I want to check is the shared box, because basically what I mean is that means these attributes are going to share this line. So you have to check. So all the entities that go to this queue are going to share the same queue. And I'm just going to pick them based on the lowest attribute priority, and that's it. So make sure to check the shared box. That means these different entities that are going to get to that queue are going to share that queue. That's all it means, but you have to check. Make sure to save, guys, before we proceed. Let me put my laptop to the charger. Okay, make sure to save. Then pretty much we are done. Let me see where we are. So if the call is technical, we have processed it, we are good. If a call is a sales call, we have processed it, we are good. If a call is the order status, we have processed it. And then if they need additional question, we also have finished the processing here. So the only other thing we need to do is just to just let them leave the system. And before they leave the system, we want to record a couple of things. Before they leave, we wanna, okay, what do you think are the things that we have to do before they leave? The very first thing. So here they used some of these technical, okay, sorry, before we even get to that part, let me just say that. One other thing in the simulation that was told to us was that I have 2 people that are taking care of these parts, 3 people, and 4 people here. And here in the simulation model so far, I just defined the resources and I said, oh, I need 1 resource of each type to answer these calls, but I haven't told the simulation that I need 2 of these people, 3 of these people, 3 of these people, and 4 of these people. How should I do that?
Go to resource and define.
Go to the resource. Here for the trunk line, we initially said, okay, I have 26 of them. But for the people for technical support for product 1, I have 2 of them. For product 2, I have 3 of them. For product 3, I have 3 of them. And for the sales people, I have 4 of them. Make sure to change the capacity of these resources so that we know how many of each we have. And in all these processes we put here, either the release was inside the processes or was separate, but if we got a hold, if we seize these resources here, we release them. So we are good in that sense. What other resource this entity has seized that has not released yet and has to release it before it can leave the system? What is the resource, the first resource that I seized? Yeah, so Akash said in the chat, trunk line, yes. So remember when the entity came to the system, before even we decide what type of call we get, as soon as we found, oh, we have a space in the system, we have trunk line that is empty, we just immediately seized the line, and then we decided what type of call we have and so forth. So, and this line was with us throughout the whole process. We didn't release it at all. If the call is done, has been answered, and it's going to cease there, and it's going to leave the system, the very first thing I have to do is to release that resource. So first, then I need to bring a release module here and just say release trunk line. And the resource that I'm going to release is trunk line. I'm going to just release one of them because I'm just holding one. I'm seizing one, I'm going to release one. Okay. Make sure to save. And then, remember when the calls came to the system initially, here we defined a variable, we call it total working process, to calculate the working process in the system, how many calls are in the system somewhere waiting in the line or being answered with someone. I want to know my working process, the number of calls in the system. And to be able to do that, I define a variable as soon as the calls are in the system. And as soon as they seize the trunk line, I'm going to increase the value of this variable by 1. Okay, remember that's what we did. I'm going to increase the value of this variable by 1. Now, but that's working process. Now, when the entity is going to leave, what should I do with this variable? Entity is leaving the system, the call is leaving the system. It's no longer my working process. It's no longer somewhere in the system. What should I do then?
You should do work in process -1.
You should decrease the working process by 1. So let's use an assign module. And here we say decrease working process or decrease active in the center. And for that, what I need to do, I need to work on a variable. What variable? It's not a new variable. I'm going to work on the total working process that I already have defined. And what I'm going to do is to deduct it by 1 and save it in the same variable. So this is basically what this expression means. So I'm going to work on the working process variable. I'm going to update that. What do I need to do? I'm going to deduct it by 1 and save it in the same variable. That's what's happening here. Okay, so that will decrease active calls in the system. Oops. Okay. And lastly,
Professor, on the assign module you just did, don't you have to assign the variable to be total work in progress? Or I'm sorry, progress.
I already did here. So when the entity came at the start, as soon as they seize the trunk line and they are in the system, here we put an assign module, and here I define a variable, we call it total working process. And as soon as the entity finally sees the trunk line and is in the system, I increase the value of this variable. Okay, so that's what we do. Every time an entity comes to the system and goes through this line, I increase the value of this variable by 1. But this variable is a global variable. I can change it everywhere in the simulation. So that's where I increase it by 1 every time a new entity comes to the system. And also, when every time an entity leaves the system, I'm going to just call the same variable, and I'm going to decrease it by 1 and save it in the same variable. So as a result, the value of this variable at any point of time can tells me how many calls are in the system. Does that make sense?
Got it. Thank you.
Sure. So that was a good question. So I already defined this variable at the start. And also pay attention that these are global variables, meaning that when you define them anywhere in the simulation, you can change them and update them anywhere else as well. So that's why we call it global variables. We can call them at any point of the simulation and change them. And lastly, I want to also record completed calls. Record completed calls. Again, this is something that simulation automatically calculates for us, but just for the sake of learning. It's going to be counter, and this is going to be completed calls. I'm going to increase it by 1. Every time an entity passes this line, passes this function, this module, I'm going to just increase this counter by 1. And lastly, I'm going to dispose this entity. Obviously, I can't just leave it in the system somewhere, right? I'm going to dispose it. Dispose of call entity. Okay, so make sure to connect all these. And also, this is basically the end to the calls. Even if they are technical calls, product type 1, after we are done, we want them to go through this path. If they are product related to product 2, we want them to go through this path. Product type 3, we want them to go through this path. Sales, the same. If they are order status checks that do not have sales question, the same. And if they have sales question and they have been answered, the same. Okay. So that would be the end for all these routes we have in the system. Okay.
Professor, I have a question.
Go ahead.
For the delay we had on the order status, I think we already have that in front of those. I mean, yeah, that one. I think we already have a delay module in front of the determined call type, which is the design module, the one before the design module.
But this is for this part. This is for call type. This is for this part.
Yeah, because I think those are the same, right?
Wait, let me think. Oh no, this delay is this part. Sorry, I put probably the wrong. So this delay, thanks for bringing it down. So this delay that I need to put here. So if it's order status, I'm going to assign different blah blah, and then it's going to take this much time to check an order status. I'm not going to seize any resource because it's just the order status is answered by automatic recording. I'm not going to seize any resource, but I'm just going to impose a delay of this much time so that I can the automatic recording answers those order status calls. So delay is there, but the delay time should be this much. I think the delay time that I put there is wrong. Yeah.
No, I think you have another one for that delay time, which is the one after the.
Here. So give me 1 second. Let me first of all make sure everyone gets this part correct. 2, 3, 4. Triangular. 2, 3, 4. Okay. So, guys, before I continue answering your question, guys, everyone, please, for the order status call, this other else, after we assign an entity time and a picture, click on the delay. The delay time that I had put was wrong, so I put uniform, but the delay time, as we see here, the checking the order status is going to check this much time, is done by automatic answering machine. We are not using any resource or anything. We just need to impose a delay for this amount of time. And after the delay is over, then we have to check. 85% of them need to ask some questions from the salespeople. 15% of them have to ask some question from the salespeople. 85% of them have no other question. They are good to go, good to leave the system. For those 15% who have to ask question from the salespeople, then this delay part shows the time that they need to talk to a salesperson. That's not the time for their order status. The value is the same. It's the same values, the same distribution, but it's the time to talk to a salesperson. It just happens that these are the same, 2, 3, 4, 2, 3, 4. But they could be different. But this delay time is for answering to a salesperson. This delay time is for finding the status of your order through the automatic recording. Does that make sense?
Yes, thank you.
Thanks for pointing that. From this graph, for a second I put this, but this is the delay time for checking the status of the orders. Okay, make sure. Okay, so guys, save. One last thing we have to do before we run the simulation is that if we go through the run setup, everything here is good. For the base time limit, put minutes so that we see everything in the system as limit. The condition, so here, what I have done when the entities come to the system, here, all I have done is that I have told the simulation, do not let any new entity comes to the system after minute 600. That's all this part is doing for me. No other entity comes to the system when I pass minute 600. However, simulation is going to still continue running. Simulation doesn't. Simulation continues forever. It's just that no entity will come to the system. So I have to tell the simulation that do not continue forever. Just continue till everyone who is in the system gets the service and leaves, and then stop. And that's what happens in every terminating system. in a supermarket, in a call center, in a barber shop, and so forth. The rule is that after some point of time, we don't let any new customer to come in. That's what we did here. However, we run the simulation or we run the system only up to the point that all the customers or all the entities that are in the system get the service and leave. So how should I do that part? I haven't told the simulation, the second part. So if we go to the run setup, here I'm going to put it as a condition here. That's the terminating condition for me. So what is the terminating condition here? So I'm going to say T now. T now returns the simulation time, right? So that's what we know. We already have used it. T now is a keyword that returns the simulation time. So I want to say, first look at the simulation time. If it's greater than 600, meaning that I'm past 6 p.m., and what is the other condition I have to check? I'm past 6 p.m. Go ahead.
Max entities exceeds 999,999.
But we may not get that point. That's just one very big number, but we may not really get that.
All the customers should leave the system.
But how we already have
no WIP thing.
Okay. So the other thing, does anyone else want to answer?
It's the total WIP equals to 0.
Exactly. So so I need to check two things. One, have I passed 6 p.m. and are all the entities calls that are in the system out? How did I track the number of calls that are in the system? By total work in process variable. That's why I calculated that variable in the system. And when that is equal to 0, meaning that no one else is in the system, then I'm going to stop the simulation. Remember, just pay attention. I have to put these both conditions, because if I just say, oh, when there is no call in the system, what if I'm just 10 a.m. and it just happens that no calls are in the system? Then the simulation is going to stop. So I don't want that to happen. I want to first pass the 6 p.m. After that, check this other condition, that if no call is in the system, then we are good. We have processed every call, we are good, and we are good to stop. And that's why I calculated work in process in the system, because as I told you, work in process, as you all have seen, is something that simulation automatically calculates for you and reports to you when you see the results. But you can access to that report, like we are running the simulation, right? So you have to calculate working process yourself in the system. And that's why we defined that module to, what was it? That's why we defined the total working process module. We assign it and increase it by 1 here, and also decrease it by 1 every time an entity left the system, so that we can get an update on total working process. And as soon as we pass the 6 p.m. and it's 0, we are going to stop the simulation. So make sure to check the unit of time as minutes. We already have a stop condition, a terminating condition. I'm not going to change anything else. And let's run. Hopefully no error. Let me check if I have the right name. Oh, I see. It's z equal. So it's not just equal. It's equal in Arena is equal to equal. And just make sure I have the same. Okay, so greater than 600 and total working process equals 0. And we run the simulation. Number of entities that have left the system for me is 7. So if I click on the entities, you see here, I have incoming calls, which are the initial entity I define. I have also the cutoff entity, which was that virtual entity that I just defined for taking care of the terminating system. But then I also see it for order status entity, sales call entity, and tech call entity. And I defined these three only because I defined the entity type. So then the simulation reported the results for each entity type separately. So that's the advantage of defining entity type. So I see the value at the time, the non-value at the time, the wait time, transfer time, I don't have anything. And so if I click on the other working process, so I can see the number of entities in the system. So technical calls obviously are more because they were 76% of the call, and then 16% were sales calls, and then only 8% were order status calls. So we can see the working process for each one of them. We can see information related to queues, resources, order status. We define 3 counters, right? We recorded attempted calls, completed calls, and rejected calls. So out of that 711 incoming calls, 41 of them were rejected and 70 of them were answered. Remember, when the calls came in here, when the calls came in here in this record module, if there was no trunk line, I recorded the number of rejected calls. And then here in this record module, I calculated the number of attempted calls. And then here I calculated the number of completed calls, because some of them were rejected. Of those that were attempted, some of them were rejected and some of them were completed. And all these 3 recorded values are the ones that I see here. Of 711 attempted calls, 41 of them are rejected. So if you are the manager of the call center, you can get a sense of what percentage it is and if that's a good value or not, and so forth. So that was, basically this, the structure of this model. We learned a couple of new techniques. We learned how to use decision modules that are more than 2 conditions by chance. We learned how to use decision modules that are based on the condition. We learned how to calculate current number of resources that are busy, current number of resources that have been scheduled to work, NR, MR. We learned, this part is important, we learned how to model the terminating systems and how not to let any new entity come to the system after a specific time. And also we learned how to make sure the simulation runs till every entity that is in the system is out. So you have to do both the part, this part 1 and this part 2nd part, for the system to be a terminating system. Do not let anyone to come after 600 minutes, and continue the simulation till everyone is out. And let me just run this one more time. Just see one thing I want to show. Okay, so you see here, the simulation time is 637 minutes. So what does that mean? It means that, yes, after time 600, I did not let anyone to come into the call center. However, the call center still had to continue working for another 37 minutes. So we process every call that were in the system. So if I ask you sometimes that how long we have to run the system so that we answer every call, then this is the number that you have to report. This call center has to run for 637 minutes so that all the calls calls exit the system. And what else we learn? This part is also important too. So if we capturing priority, guys, you are going to use this a lot. This is a very, very important feature of the Pro model. How different entities that are waiting to get processed by the same resource can have different priorities. This is used in call, especially in service industry a lot. Calls, some of them are VIP, some of them are regular. If you model hotel industry, barbers, supermarkets, all of them, you can have entities that have different priorities. Even in the manufacturing industry, we get maybe some orders that are VIP customers, some that are not. So the question is that how to capture the priority of these entities as they go through the simulation, and how to build the simulation that use these priorities to process the ones that have higher priority or lower priority first. So we learn how to capture that part as well. And what else? Yeah, and generally use more of the modules in advanced process, and the fact that advanced process have modules that are basically the detailed part of the modules that we see in the basic process. In the basic process, we see a process, but here we see process, we see delay, we see release. If we need to use them separately, we can use that as well. Make sure to save and let me know if there's any question. No question? Okay. So what I'm going to do is to edit the video for our class today and upload it as soon as I can and assign the next homework. Have a good day, guys. If there's no question, have a good day. I'll see you next week. If there's any question, email me.
Hi, Professor.
Hi.
Are you still there? Yeah. My model got some problem. Can you help me see it?
Go ahead and share your screen.
Okay, thanks.
Sure.
Can you see my screen?
Yes.
Okay, so when I click, it gets some error.
Let me see. Process. Okay, for the queue, I know what you do. Go back, close.
Yeah.
Go back to the queue module, queue data module.
Queue, right.
Yeah. Remember shared? Look at the last column, shared. The column. Yeah.
Last column.
Yeah.
Shared.
Yeah.
So,
or you can
this
just change it. So you have to check that, otherwise you get error. So check the shared box.
Oh, I get it.
Yeah, because that tells the simulation that this queue is going to be shared by two entities. The cells, the calls entities, and then the cells calls entities. All of them are going to share this queue. So you have to always check the shared box. Run your simulation.
Yeah.
Yeah.
Okay.
You're not getting it. Yeah, around the same number as mine. Mine was 714. That's it.
It's a lot different.
No, mine was 714. That's not a lot. Mine.
Okay, so this difference seems okay.
Absolutely. Let me check. Mine is mine is 735. Okay. So if you look at your number, if you look at your model, you see that where is it? If you look at one, so basically the difference between our models is 34 units, right? But the magnitude of the number that we are dealing with is 700, right? So just
Yeah.
10, 20, 30 up or down is nothing compared to the scale of the number. If you would see 701 and I would get 300, that would be a significant difference. That means something is wrong in one of the models. But given the magnitude of the number that you get, 700, then 20, 30 units up and down, that's just because of the randomness in our models. You will see that later when we run this model for different replications. Every replication on your computer, every replication leads to a different number of entities out. One is 701, one is 650, one is 750, but that's fine. That's just the difference in randomness. So the same, if for example you run another model and your output is, for example, 10,300, and let's say my output is 9,900, right? So the difference between my output and yours is 400, but 400 in the scale of 10,000, right? So absolutely an ignorable difference. So the magnitude of the output is 10,000. Now yours is a couple of hundred more than mine, no big deal. But if yours was 10,000, mine was 6,000, I would say, yeah, that's a big difference. That's 4,000 in the scale of, yeah, you know, when the scales of 1,000, then thousands of differences is a lot. But if in the order of 10,000, just a couple of hundred ups or goes up or down is nothing. So just always look at the scale of your output and then see the magnitude of the difference. And if that magnitude of the difference, given the scale of your output, is not much, then it's absolutely okay, and it's because of the difference in randomness.
I got it. Cool. Thanks, Professor.
Sure.